everyone. Today we are printing conductive traces, running a bake cycle to cure the conductive ink. Then we are printing a solder paste layer, placing parts on the solder paste, and then using the reflow oven function on the Voltera to create a Hello World circuit. The circuit is built into the Voltera software. Really kind of a nice feature. On the top, in red, is the conductive ink layer. In white is the solder mask. On the bottom half of the screen is the circuit schematic. Here's a photograph of the circuit taken with a macro lens. Here's a detail of the battery contacts. For this circuit, you sit down a 9-volt battery on the battery contacts. They're held down with gravity. It's pretty neat. You can see here that there was an underflow with the conductive ink. And you can also see that burnishing didn't really take off all of the surface impurities. Here's a detailed photograph of the capacitor. I'm not seeing the filleting that I would really like to see with reflow. Here's a side view of the 3 LEDs, and you can see some tombstoning. What I've learned is that this is expected with the Voltera printing process. When the solder paste is printed, there's a dimple that often results. So if you place the parts and you don't really kind of mash them down, then that dimple will hold the part up and you'll get this tombstoning. You can see that the proper amount of filleting, which is a nice transition between the part and the pad with solder kind of filling in, it's working here for the LEDs. We don't see that with the capacitor. So I'm trying to figure out why, whether it's my fault or whether it's a problem with the reflow heating profile. Here's a top-down view of one of the resistors. So you can see that the solder is not really covering the pad like I want. The feedback I've gotten so far is that perhaps the solder paste is underflowing from the printer as well. These are all things that are under my control, so this part of the process is learning how to make the prints turn out really well. And the Hello World circuit is an excellent way to figure all that stuff out so that any prototype parts or prototype circuits or prototype prints that we want for Phase4 ground are good. This is in the Voltera app, and this is the Reflow Profile. So you can see how, with respect to time, the temperature is brought up to various levels and how the printer responds. So these profiles are they're built into the Hello World, and they come from your choices in terms of which ink and which solder paste you specify that you are using in the setup to the printer. The Joko Cruise is this weekend, and our badge project is entering the final stages. Here's an update from the team. There will be plenty more reports and feedback about the badge design over the coming week as the Joko Cruise embarks. Several of our team members are on the cruise, and we can't wait to hear all about it. Everything that we've learned on this effort will be applied to the Hamvention badge and to the Phase4 ground radio. We have some software-defined system-on-a-chip progress. We've received our Xilinx specific JTAG cable. It's the Digilant HS3. Charles Brain has been battling Petalinux and Linux builds for his environment. Plenty of learning is going on there. Some of us have received additional hardware from Lime SDR, and there is more on the way. We have received very positive news from Critical, the makers of Snickerdoodle, and that news is the official board definition files are in progress and will be available very soon. This means that those of us that are ordinary tool users and not necessarily advanced tool makers will be able to experiment and make progress with the Snickerdoodle, Xilinx Vivado, and the Xilinx SDK more easily. SDSoC allows you to take functions written in C and C++, evaluate whether they would be better run on either the general purpose processor or the FPGA, and then assign them to the proper hardware. The 5 GHz RF team is learning a lot about the impact of connectors on performance and are evaluating some higher quality solutions. Several sets of team members are working on transverter designs. This is a very active and interesting area of investigation. There's a very large number of trade-offs and design patterns involved. We have a 10 GHz specific effort, a high-performance multiband effort, the 5 GHz RF team previously featured, and more. Ed Friesma at UNLV is taking on more of the correlator design. Our next report will be all about the progress on the DVB-S2 correlator, the GNU radio block, what we can leverage from the GPU implementation, and next steps. On the 28th of February, we'll have 2 guest speakers at our regular Ascent conference call. Nate and Neil from Edis Research will be on the call, and they will be answering questions about the careful COTS design of a USRP 300 series board for use in space. Having a powerful SDR at the heart of an amateur radio payload would put us in an excellent position to deploy any modulation scheme we want. The careful COTS version of a USRP is why Phase4 Space was founded. We've had a very good week in terms of outreach and evangelism. There's good news in an update to the Phase 4B mission on the Wide Field of View satellite. There's a launch scheduled for 2020. You can read about it in the article linked in the notes from this past June. Our job on Phase 4 Ground is to make sure that you have a radio that you can use for this or any other payload that uses the 5-and-dime air interface. And of course, we want to fill up the terrestrial microwave with the same fun and easy-to-use broadband digital microwave signals. If you're interested in learning more, then get in touch. Plenty going on and lots of fun to be had. We will have a booth at Dayton as soon as possible, and we will be asking for time to talk at the Hamvention SDR forum about the Careful COTS effort, open source successes, and the impact of SDR advances on both licensed and unlicensed services. After Hamvention is DEFCON, and we might have something up our sleeves. I'm working very hard on setting up a workshop in Hackfest at the GNU Radio Conference for 2018. This will be held September 17th through the 21st in Henderson, Nevada. This Hackfest, or workshop, will focus on developing GNU radio receiver blocks for DVB-S2 and S2X. If you are on the team or you're a supporter and you find yourself interested in all of this, then please consider coming to the conference and participating in this effort. Tickets will be available very soon. It's a volunteer-run event made possible by people just like you. And there's an open space initiative from Lockheed Martin that we need to take a serious look at. And there's some new products on the market that might make our GSE and DVB-S2X manufactured solutions a bit easier. Howie DeFelice is on that trail, and he'll report back soon. See you next week.